Okay, this question too is quite similar. They have also asked us to split into partial fraction before we do our integration. So that is a very obvious hint. But the thing now is, oh, this particular partial fraction is power 2. So this is a repeated root. Can you remember how to split a repeated root into partial fraction? So if it's repeated root, I have a 3x minus 2 to the power of 2. I must have 1 with a power lesser. So it's into 2 partial fractions. And same thing, I'll write an A and a B on top. Using the same technique, oh, the obstructive thing is the fraction. So I will always multiply by the original denominator. So in this case, this is my original denominator. So now it's our job to solve for the respective value of A and B. And in this case, we also want to make the bracket term equal to 0. So let 3x minus 2 be equal to 0 means that we will use x is equal to 2/3. Alright, if there are no other bracket terms, it's always very easy to use the convenient value of x, which is x is equal to 0. Using the value of A we found in the first part, I will get my B to be equal to 1. Now remember to write the whole partial fraction out. Even though there is a fraction, remember numerator to numerator, denominator to denominator. There you have our answer to part 1. But we have to do the second part. Remember, we don't have the ability to actually solve for the integration for the second part. But we are supposed to use our answer for part 1. So let us do our integration using our answer. Before we do that, we will need to simplify. Apply our normal integration. Alright, we will need to add 1 to the power, divide by the new power, and we also need to divide by the coefficient of x. And remember, for those with a negative 1 is a special case. We will need to have ln to the bracket term, divide by the coefficient of x, and please remember to indicate a plus c. Now we just have to simplify it. And there you go. This is our final answer. Please remember to underline. Okay, some of you could be writing your first term as my portion in black. Yes, you can also write in that manner as well.